Hey, welcome back, AP Stats. Hopefully the audio is better. I've been trying to make a couple of changes. And so, here we go. We're going to talk about how to represent, we spent yesterday talking about how do we represent categorical data, and today we're going to do it with quantitative data. Normally, I would ask you guys to go up to the board and write down the number of shoes that you own. Something simple. A lot of people don't have a lot, to have under 10. You always have somebody like this person over here at 37. I had one person last year who had a couple hundred because he collected them. And so we go through and do that. And as a reminder, when we ask you for a number of pairs of shoes, is it categorical or quantitative? If your answer is a number, it's going to be quantitative. If your answer is a word, that's like a category, etc. And yes, I know numbers are words. Just stop, okay? If it is a non-numbered word, non-numerical word, how about that? Then you're going to go through and you're going to say quantitative. So the first thing that we're going to end up doing here is that we're going to go over and go back to StatPlot. So just make sure that gets transitioned over. Beautiful. Still learning OBS. So we're going to go through and we're going to say we have a single group quantitative variable, or quantitative variables, and we've got pairs of shoes. And inputting, you do have to be careful sometimes because it's easy, especially with long runs of numbers. You can get lost in terms of how many you have. So 1, 2, 3, 4, 5, 6, 7, 10s, 2 11s, 2 13s, a 19, 3 20s. I know. Exciting stuff, right? So then begin analysis. So here's our dot plot. And again, dot plots are very nice. You can see spread very nicely. And we're going to talk about how you describe these things today. But just, I mean, as you look at each of these, think about how you would describe them to a friend. It's really spread out. It starts at 3, ends at 37. The most that we have is 10. It seems to be bunched up down here on the lower numbers. It's more spread out on the top, that type of thing. And again, this is nothing necessarily new that you have done. What I'm trying to do is get you thinking of the questions that we'll have, and then I'll give you the language, what you'll need to sound smart when we talk about this. Another one that you're going to be asked to do is a stem plot. You may know this is a stem and leaf plot. This has the same benefit as the dot plot, as you can know exact numbers. So I know this is a 3, this is a 4, this is a 5, partly because there's this key down here, which is really important to go through and do. Because that way you know that 3/7 is 37. This could be 3.7, it could be 0.037. You can do stem and leaf plots in a whole number of different ways. But again, you can kind of see this spike happening. That we do have a lot of people who have somewhere between 10 and 19 pairs of shoes. And then there's the histogram. Histograms tend to be confused with bar charts a lot. Bar charts are used for categorical variable. There is usually spaces in between those. For histograms, there are no spaces unless there is a gap in the numbers. So here, all we know is that we've got three numbers of pairs of shoes between 5 and 10. Now notice we don't have the exact data like we did with the dot plot. Okay, over here we know we go up to 11. They could all be 10s, they could all be 14s, there could be a mix of whatever. We don't know, but we just know that there's a bunch there, etc. Here with stat plot, you can say, okay, instead of going by 5s, maybe we go by 10s. And then the boundary value, we're going to start at 0 because you can't have negative. A couple of things notice, we've got frequency over here, that's counted up across the top, and then we've got pairs of shoes across the bottom. So again, everything is labeled, okay? So that is important. So as we go back, let's see if this cuts back like I want it to. Yay! So then what I did is, I have you guys make each of these, and the reason why that's important, excuse me, should know where the mute is on this somewhere. A couple of things that are going to be important here. Keys are a must-have, okay? You need to be able to explain what this means. Notice down here, I've got number of pairs here. Okay, so I've labeled that. And like you would have a title, so let's say like shoes from AP Stats, shoes owned from AP Stats. Okay, same thing over here. The only thing which I haven't done here on the frequency, again, label is important. And then over here, I've got frequency, and I really should have boom, 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 the numbers going up on the side there. Okay. So, all right, so here's the description, and this is going to be one of those things that are really, really going to be big. So shape, some things that you need to worry about, or the ways that you're going to, I shouldn't say worry about. You need to worry about the shape. You need to worry about the shape, the outliers, the centers, and the variability. You need to worry about the symmetry. Is it symmetric or not? Remember, symmetry, a triangle can be symmetric because you can put a mirror on both sides. These are the same, so these would be symmetric. Oops, we can't see that. There we go. Those would be symmetric. I suppose we could go right about there. You could also say, is it skewed left, skewed right? We'll talk about what those mean. Skewed left means that the data falls to the left, so it'll look kind of like this. So it's kind of pulled out. So like up here, this would be skewed right because most of our data is spread out to the right. And we'll talk about how that all falls when we start doing numbers and quantities. So skewed right would look something like this. Goes up and then it skews way out like that. Okay. Outliers we're going to talk about. We're going to get a rule for this. I'm going to guess that many of you guys have seen something about that. It usually means something way out there. And we'll have a specific rule which will kind of govern what's an outlier and what's not. Center. What measures a center, do you guys know? Could be a mean. This could be a median. Which one do we use? We'll talk about that too. Variability. How do you know how varied this is? Now, right now, what we're going to talk about is range. So how spread out is this data? The more spread out it is, the longer it's going to be, the more variable it is. If it's really compact, then it's going to, if it's really, should I do down here or up here? If it's really compact, then it's going to be less variable. Okay? So out of these three, and this is a question only you can answer, is which of the three types of display do you prefer and why? There's benefits to each. These two, you can each see individual pieces of data. This spreads out and you can kind of see each one. This one's kind of nice because at least it kind of gives you an idea of a histogram. If we went like that, it's very similar to what we did up here. Okay, notice 10s are bigger than zeros. We've got two small ones down here. That's exactly what we have over here. The benefit of histograms is that, especially if you have large amounts of data, you don't have to write all the individual pieces of data. Okay, so there's all that. So what I would like you to do is take a second, you can check it versus stuff. You can do this on a separate sheet of paper, it's fine. Is I want you to go through and, so these are teachers here. Okay, ask his colleagues, those are other teachers. Okay, to record the number of shoes that they had. The results are below. So now here, this is when we go into Stafflet, you're going to have two different groups set up. Okay, so for that, we're going to go back to the original. Boom. And we're going to say multiple groups. It's a variable name, pairs of shoes. And we're going to say students. I should have just copied them, dang it. You know, what can you do? Sometimes it's different. So we've got 3 and 3 and 4 and 4 and 4 and 6 and 8 and 8. 10, 2, 3, 4, 6, 7. How was class today? Well, I heard Mr. Hayes just recite numbers for fun. Hey, you know, people pay to see that sometimes. All right, so if we do teachers, here we go. So I've got, now you don't have to type these in order, which is also a nice thing. Yay, technology. And now if we begin this analysis, we get this. Whoa, what did I type? Oh, I see right there. 10,011. There's my mistake, right? Edit inputs. Boom. Hey, that's better. So now when you look at this, the question is, what's the difference? Students are more diverse. They've got a wider range. That would be one way you could explain it. Okay. It's going to be interesting to see what measures the center. This is pretty clearly the center. Okay. It's going to be somewhere in here. Here, it's going to be harder, probably something a little bit higher. If we go to the stem plot, now this is called a back-to-back stem plot. Why? Because we've got students on one side, teachers on another. You've got the stem down the middle. So you know, again, this is 37, this is 35, etc. So it kind of gives you a sense. Now this, as opposed to what we did with the dot plot, notice we still have the most in the tens by teachers, and we still have the most in the tens by students. And so maybe the means are actually going to be closer to the same. And then if you do histograms, same idea. Let me get this high enough so my head doesn't block it. So again, an interesting kind of setup. I'm going to make those by tens again. So again, it's very similar to what we saw with the label, or with the stem plots. Okay? So with that, then, the question becomes, what do you do? Okay. Where'd your other sheet go? I'm going to come back to here for a second. There we go. Hi. When you're describing things, let me do this in a different color. For your descriptions, use ly words. Okay. So use adverbs that, because you're actively describing the verb. So we'll talk more about that as we go. So back to the end here, or almost end. So here you would end up drawing those things out, and you'd only draw one. And then in terms of this, when you describe these, you need to do the following. Okay, so as I said, we need to know the shape. Okay, I'm going to call up my screen here real quick. So we need to have shape. We need outliers, which we'll talk about later. Center, and variability. Okay, so if we come back here, all right, you can see that you'd say something to the effect of both the student and faculty numbers of shoes owned are skewed left. Excuse me, skewed right. And again, why skewed right? Because this is kind of where the center seems, and this side is more spread out. So for outliers, the big question is, what is the outlier? You might have one up here. You might have one here. We're not sure yet. To be determined. The center for students seems to be between 10 and 15. Same for the teachers. Center for students, shoes owned. And for variability, we would say there seems to be less variability, and this is where the dot plot comes in really, really nice. And I'm writing this down, and you can't see it. Sorry. Where is it? Dot plot. There we go. So again, since it's the range on the teachers, so actually let's do this. pause, obviously, if you're doing this live at home. The student shoe range is, go back to my data. So what we had a maximum of 37.3 is 34. That's 37 minus 3. And the teachers is less variable. With a range of, maybe I will fill these out ahead of time. That might go faster for all of us. Well, we'll see what we can do about that. And then the teacher's range, what? We went down from 6 is the smallest, up to 35. So that'd be a range of 29. Okay. So you need these. These are needed. And you need context. So if you just said the graphs are skewed right, that's not good enough. You need to talk about what are we talking about. Okay. We also need comparative language. Sorry. And the reason why you need comparative language here is because what will end up happening is that here they're both skewed right. So that's what how they're the same. These are different. Okay. So you need to talk about what's the same between the two sets of data and what's different between the two sets of